So last time we talked about this definition of theorem 68, but I know there were some people that weren't here, so I'll give you a second to write this down. Is there anybody that doesn't have their 9.3 notes with them today? You? Were you here?
Yeah.
Okay, I can get you a new copy. So theorem 68 says, if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the given right triangle and to each other. So if you guys had looked at the definition of theorem 68 while you were working on your warm-up today, you would have already known the answer to part C, because it is right here. All right, so now we're going to go a little bit more in depth. Oh yeah, the triangles are all similar. So now we have the color-coded theorem. And this is Ms. McClanahan's. I'm colorblind. I didn't come up with this. This is not my thing. But I think it is a great tool, and for you color-oriented people out there, you are more than welcome to do this. I recommend that you use your colored pencils along with me. I will do my best to get the colors right. So we are working on the color-coded theorem. It says that green is the geometric mean of blue and yellow. And apparently, if you combine blue and yellow, it gives you green. I think that's something they talked about in like art. It didn't stick with me. Primary colors, secondary colors. Yeah. So green is the geometric mean of blue and yellow. All right, and the first way we're going to use this is to show our x over h equals h over y. So we can see x and h and y, and so we label our geometric mean green. So our geometric mean is on the bottom of the left-hand side and the top of the right-hand side, just like we know how to set it up in a proportion. And the geometric mean is green because mean and green rhyme, so that's easy enough to remember. And then blue and yellow are going to be the x and the y. And just so you guys know, blue and yellow, they are reversible. So I could have had x as yellow and y as blue, but because they are interchangeable. So green is the geometric mean of blue and yellow. And we have our altitude is the geometric mean of the independent segments of our hypotenuse. So this is an informal definition of theorem 68 part B. The more formal definition of the theorem is this. And just so you guys know, this is going in part B of our notes sheet that we got on Friday. All right, so what theorem 68 part B says, if an altitude is drawn to the hypotenuse of a right triangle, then the altitude of the hypotenuse is the geometric mean between the segments of the hypotenuse. And it's very important that you guys can understand what this means, because we're going to be quizzed on this in a couple classes. So there are going to be some fill in the blanks, and we're going to have to know the definition of theorem 68. So we're going to need to know how to use it.
sure you all, the colors are going to be different for every triangle. So the ones he just put up, that is just for part B. The green, blue, and yellow will be different for each picture on the page. So the colors we just put up are for the triangle under part B.
All right, I think we still have a couple of people writing down theorem 68 part B. So over here on our very stable easel, we have it copied down so that we can reference it for later. And it's just exactly what the previous slide said. All right, so the next geometric mean is going to be represented using green as the geometric mean of blue and yellow, but it's going to show a different proportion than the previous one. So this is going to go on the first triangle that we have under part C. So the geometric mean is B, and it is the geometric mean of the entire hypotenuse C and X, the segment of the hypotenuse that is adjacent to that leg. So remember, the geometric mean is always green, and it is the geometric mean of blue and yellow. All right. So we can say the same for the other leg. So in this case, A is going to be the geometric mean. That's why it's green, because it is the geometric mean of the entire hypotenuse and the segment of the hypotenuse that is adjacent to that leg. And this is going to be the second triangle under part C. All right, so now I think we are ready for the definition of Theorem 68 Part C. It says that if an altitude is drawn to the hypotenuse of a right triangle, then either leg of the right triangle is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg. So it looks like most people are still writing, so I'll give you a couple more seconds. All right, so if you didn't write down the proportion associated with the three different geometric means that we identified using the color-coded theorem, they're written up here. So make sure you have those written down, because the geometric mean, the proportions, are the most important thing that we're going to be using in this section to solve for the unknown sides. So proportions are the most important thing. And you may notice that the three proportions that are written over here on the easel are the same three proportions that we found in our exploration over the weekend that we did last class on Friday, and then we went home and found the proportions. All right. So now, I think everyone's getting close to finishing writing down the proportions. So now we have the Mr. Roberts method. It's not color involved because I don't like colors. So the first step in the Mr. Roberts method is to identify the right angle of the largest triangle. So in this case, it's going to be the right angle that's at the top. We're always going to, even if the problem gives us a right angle or a right triangle with the altitude drawn, we're always going to want to orient it this way so that the right angle is at the top. It's going to help us. So we might have to twist our paper occasionally, but we're going to look for the right angle. The second step is to check to see if any of the line segments that have an endpoint at the right angle are given values or unknowns. And what this means is, all right, it could either be our altitude or either of our legs. And if we know information about the altitude or either of the legs, then those are going to be the geometric mean that we're going to be working with. All right, and the final step is that the leg or the altitude that we identified as our geometric mean, it is the geometric mean of the two parts of the hypotenuse that share an endpoint with that leg or altitude. And what I mean by this is, so for example, let's look at Theorem 68, Part B, number 1. So let's say our geometric mean is our h. It shares an endpoint with the segment of the hypotenuse labeled x and labeled y. So h is the geometric mean of x and y because it shares the endpoint with those two segments of the hypotenuse. For number 2, or 68 part C, we have a leg. And the leg is going to share an endpoint with the segment created by the hypotenuse and the altitude and the entire hypotenuse. So the leg is the geometric mean between the hypotenuse and the segment of the hypotenuse between the endpoint and the altitude. All right. So I'm going to be using the Mr. Roberts method when I'm doing problems. I'm still going to identify the geometric mean as green, so the color people will be somewhat in luck, and I will try my best. So I'm going to go ahead and move on to working some examples. I think they're on the back of your notes.